In this video, we will solve GATE 2022 MB Set 2 question number 62. This question is from the topic fluid mechanics. The question is a uniform wooden rod of specific gravity 0.6 diameter 4 centimeter and length 8 meter is immersed in the water and is hinged without friction at point A on the water line as shown in the figure. A solid spherical ball made of lead of specific gravity 11.4 is attached to the free end of the rod to keep the assembly in static equilibrium inside the water. For simplicity, assume that the radius of the ball is much smaller than the length of the rod. Assume density of water to be 10 to the 10 raised to the power 3 kg per meter cube and pi is equal to 3.14, and the radius of the ball is in centimeters. Now, to solve this question, we need to know the formula for the buoyant force. So this buoyant force is the force exerted by the fluid on a body immersed in that fluid, and it is given by this formula. Here Fp is the buoyant force and it is equal to rho F times G times Vft. So rho F is the density of the fluid, G is the acceleration due to gravity, and Vft is the volume of the fluid displaced by the body when it is immersed in that fluid. Also, we need to know what specific gravity is. So specific gravity is just the ratio of the density of the body divided by the density of the fluid in which it is immersed. So rho b here defines the density of the body, whereas rho f is the density of the fluid in which that body is immersed. Okay, now let's move on to the solution. So let's note down whatever is given to us. So we have a wooden rod, and this wooden rod has a specific gravity of 0.6. So Sg for the wooden rod is 0.6. This implies that the density of the wooden rod is 0.6 times the density of the fluid, and the fluid here is water. Also, we have been given that the specific gravity of the ball is 11.4, and this implies that the density of the ball is 11.4 times the density of the fluid. Now, since the fluid is in equilibrium, let's see the various forces that are acting on the body. So here we have the point A, and this is our rod, and at the end of the rod we have a ball attached. So the centroid of this rod will be somewhere here, and from the centroid we can draw this weight of the rod which is acting downwards. Let's say this is W of rod. Similarly, for the ball, we will have the weight of the ball which is also acting downwards. Let's call this WB. Also, the rod will experience a buoyant force because of the water, and let's call this force as Fw, and this will be in the upward direction. Similarly, the ball will also experience a buoyant force. Let's call this Fp in the upward direction. Now, since the rod is in equilibrium, the whole assembly is in equilibrium, thus all the moments, the summation of all the moments at A will be equal to 0. Now we can, since this is 2, this will be some length x, and from similarity we can say that this will be some length 2x. So now taking moment at A equal to 0, we can say that this implies WR minus FR times x plus WB minus FB times 2x is equal to 0. Now let's look at what WR is. So WR is just the weight of the rod, which will be equal to the density of the rod times the volume, which is equal to pi times radius of the rod, pi r square times h times g, and the buoyant force acting on the rod will be equal to density of the fluid times the same volume, pi r square h times g. Similarly, the weight of the ball will be density of the ball times the volume of the ball, which is, since the ball is spherical, so the volume will be 4 by 3 pi r cube times g, and the buoyant force acting on the ball will be equal to the density of the fluid times the volume of the ball times g. Now putting all these into equation 1, so let's call all these expressions as equation 2, and using 2 in 1, we can say that so density of the rod, we just found out the density of the rod is nothing but 0.6 times density of the fluid, and we'll subtract the density of the fluid from this times the volume of the rod, 4 by 3 pi, and the radius of the rod will be 2 centimeters, so this will be 2 into 10 raised to the power minus 2 square, and the length of the rod is 8 times g, and this will be equal to minus 2x times again the density of the ball, which is 11.4 times the density of the fluid minus the density of the fluid times the volume of the ball, which is 4 by 3 pi r cube times g. So g and g gets cancelled, x and x gets cancelled, we can cancel pi as well. So from this expression only r is unknown, and you can solve for r, and finally we will see that r will be equal to 3.58 centimeters. So you can do this calculation, and r will be equal to 3.58 centimeters, which is the radius of the spherical ball. So we solve this question, and the answer is 3.58 centimeters. And in order to know more about bodies submerged in a fluid, you can refer to this NPTEL course on Introduction to Fluid Mechanics by Professor Sumit Chakrabarty.